In part C, the reduction of substituents bonded to benzene, most common one here is when you have a nitro group and you would like to reduce this to an amine group, an NH2, to create aniline. So if you react nitrobenzene with hydrogen gas over palladium metal, you will get aniline. There's another route, because this may not be suitable all the time. You need hydrogen gas. And is that you can use tin or zinc complex with mercury with acid, and you produce NH3 plus. However, you need one more step. So this would be step 1. And then step 2 would be the use of sodium hydroxide. You need the basic workup to simply deprotonate the H, one of the H's, so you get your aniline. Very well. So usually this is written as one step. So it could be written such as where, so I'm going to show you, it could be written like this, zinc, either one, like I said, is fine. Zinc, HCl as step 1, and then step 2 is NaOH. Basically, this is both steps in shown here. A ketone or aldehyde can be reduced using the Clemmensen or Wolff-Kishner reductions. There's no mechanism. I'm not going to show you the mechanisms because they're quite complicated. So just know what these reactions yield. These reagents do not reduce esters. This is a very important statement. Carboxylic acids, amides, or acid chlorides. They only reduce ketones and aldehydes. And you need to remind yourself what a ketone is. So a ketone is basically this, and then aldehyde in respect to benzene is this. So ketone, and that's an aldehyde. And I'm writing this. I know it should be common sense by now, but it's okay as a reminder. So what happens here is the reduction basically yields this carbon. This carbonyl is now rendered without the double bonded oxygen, but with 2 hydrogens attached. That is reduction. Now there are 2 steps, and you have to know both. The first one we kind of mentioned here, and it's called the Clemmensen reduction. Be careful once again, you are only reducing the ketone or the aldehyde. In this case, you have a ketone right here, but you don't have a ketone here. You have a carboxylic acid. So I'm just going to say a carboxylic acid. So you leave that alone, even if it's an amide or an ester. Your only business is to, again, convert the ketone or the aldehyde. So therefore, our product will be, you just get rid of the carbonyl and substitute that with H's. You will get so notice how I put them on there, CH2, CH2, COOH. And once again, here's what I added. Now this is acidic. This one follows acidic conditions, the Clemmensen. The Wolff-Kishner follows basic conditions, So it's going to yield the same product to you. So let's draw that. Basically, you have So imagine you have a benzene. Again, you just reduce that to that. And this one follows basic conditions. Basic conditions. And the reason why we have two ways is because you might have what we call acid sensitive or base sensitive groups elsewhere in the molecule. So they might be affected. Conditions. Sorry, let me just rewrite this. Not sure why they were deleted. But you may have basic the basic conditions may actually end up impeding your reaction by having an influence on one of the groups attached to the benzene ring.